Number B, solenoid of length 10 centimeter, radius 2 cm and 100 turns. That is 1000 turns. So number 1, the current of the solenoid is lowered from 5 to 0 ampere. So meaning this is the decrease of the current flow within the 0.3 second. Calculate magnitude of induced EMF in the solenoid. So let's say you have the solenoid here and the current flow. Yeah, as you know, when the current flow, the solenoid, we have produced the flux linkage here, and the length of the solenoid is given by the 10 cm, right? And the radius of the solenoid, solenoid is radius is 2 cm, and you have a number of turns, and is 1000 turns. Oh, the current flow from, like say, I1 is 5 ampere and decrease to I2 0 ampere, right? So we have a change of the current flow. So meaning with the change of current flow in the solenoids, yes, in the solenoid we have a induced EMF. So induced EMF in the solenoids is given by the questions. L or negative L can use di, the change of the rate change of the current flow. So now the question asks you to calculate the induced EMF. So to calculate the induced EMF, so the rate change of the current here, yeah, so L, or you can use negative L, you can use the L, but this is the value, because according to the this is equation, this negative. So if you not use the negatives, okay, right? Because the value is still a positive. Say the di, the rate change, the change of the current here is the final minus initial current 5 ampere in the time t, so the process decrease is 0.3 second. So now this is EMF, but so what is the value of the inductance in the solenoid? So in the solenoid, as we know, the inductance is given by the equation U naught and square A divided by L, right? So now you can use put the value U naught is 4 pi exponent minus 7, this is constant. Number of turns is that's 1000 turns square. On the area A, so how to calculate the use, because radius is 2, so you can use the pi j of pi r square. So this is radius, but make sure the radius is 2 cm. You must convert to the meter first. So the radius is 0.02 meter square. This is pi, and the length of the solenoid is 10 cm. So same, because meter use 10 exponent minus 2. So now you can find the value of the L here. Inductance for the solenoid is equal to 15.79 this is a milli, right? Millihenry is exponent minus 3. Okay, this is equal to 0.0158 Henry. So now you can use the value here, L here, to the equation here to calculate the EMF. So induced EMF is equal to 0.262 volt. Maybe you can use the negative because this is the small value minus the big value. But now the question just asks you to calculate the induced EMF. So induced EMF is 0.262 volt. Right? And number 2, so now a second coil with a 50 turns is on coaxially with the solenoids. Calculate the mutual inductance. So now you have another coil here. So I draw another coil here, use a blue color. So we have another coil in the center of the first solenoid. So this is 15 10, right? So what is the, now you have the two coil, a combination between the two coil here. So the number 2, what is the mutual inductance? So mutual inductance equation is, the symbol mutual inductance is M is equal to nu naught N1 N2 cross-sectional area A and L length, right? So now put the values in the formula. Nu naught, as you know, is constant for pi exponent minus 7, and the N1 is referred to the solenoid 1. Solenoid 1 number of turn is given 1000, right? This is 1000, and the N2 here is a number of turn of second solenoid is 50, and the length of the solenoid is referred to the first solenoid or first coil is equal to, this is 10 centimeter or 0.1 meter, and the area A is the area of the solenoid here. The first solenoid is equal to, so you can use the A is equation pi r or j square. R is radius, right? So the radius is given by the 2 centimeter, or r here is a 0.02 meter, and this is square, right? So you can find the value of the, so just right here, the mutual inductance. You can use the calculator here. This is equal to 7.90 exponent minus 4, sorry, this is minus 4 Henry unit for the mutual inductance. And the next question, what is the induced voltage ratio of the coil to the solenoid? So they're right here, right? The ratio here is induced voltage, or E coil divided by induced EMF in the solenoid, right? So the ratio here you can relate to the number of turn. So this is E coil is number of turn of the coil divided number of turn the solenoid. So now you have a number of turn of the coil is 50 turns, and number of turn of the solenoid is 1000, right? So the value of the ratio here is equal to, so 15 divided by 1000, so this is equal to 0.05, right? Thank you.